there, everyone. We are going to check those strategies that you just identified. So kiss your brain because you are doing a lot of big work tonight. Remember, I don't expect you to know all of this by heart by the next session, but I want you to have it front of mind as you work with young people and think about how this impacts the decisions that you make for them in your classroom. Also, this takes a long time to sort of absorb and understand, but there are some big ideas that we want to remember as we think about multi-digit operations. We see direct modeling by ones, we see counting by ones, we see direct modeling by tens, and we see counting by tens, direct modeling by tens, and invented algorithms. And so now we're going to go through the work. So we're going to go through it pretty quickly, but I'm just going to tell you what kind of strategy is in each one, and you can check your work. Okay? So piece of work A is direct modeling by tens, and we see the tens rods here and the ones units. B is direct modeling by ones, where the child showed each of the 36 and the 20 in the tally marks. Piece of work C is an invented algorithm, where we actually see that the young person decomposed the 4 to help them add. D is also an invented algorithm. This is more of an example of combining like units where they added the hundreds, tens, and ones together. It's actually really crystal clear if you look down here. Student work sample E is direct modeling by ones, where we see every one of the 56 children modeled. Sample F is the only example of counting by ones. So this is a counting strategy, not a direct modeling strategy, because the first 36 are not shown, and the student just counts up from 36 to 56. Sample G is an invented algorithm, where they used the strategy specifically of compensation, switching the 199 into 200 here. H, pardon me, is direct modeling by tens, where if at first glance you might think that they're tally marks, but this is the tens and these are the ones. Sample I is direct modeling by ones, where you see the 36 and the 20 modeled. Sample J is an invented algorithm. It is oftentimes people will say, oh, this looks like it's counting by tens, but it's actually called incrementing, because anytime the young person takes a chunk of the number bigger than 1, it no longer is a counting strategy, and it's actually an incrementing strategy. And this one relies heavily on place value understanding. K is direct modeling by tens, where you have to look really carefully and probably ask some questions, because they do look like tally marks by ones, but they're actually, each one is a group of 10. L is direct modeling by ones. M is another example of an invented algorithm where the student increments, but this time they're incrementing by 10 on an open number line. N is also direct modeling by 10. So you see the hundreds here, the tens, and the ones. And so we don't say direct modeling by hundreds and direct modeling by thousands. They either do it by ones, or they show some understanding of being able to unitize and see groups of groups. And so this is direct modeling by tens. And then this last one is direct modeling. This last one is this one here. D is an invented algorithm where they combined the like units. All right. Now, what I want you to do is I want you to take a look at some things in a moment that are going to help you when you interact with young people. So we're going to look at the problem-solving cycle. And remember that student work analysis